In this video, I'd like to talk about the number of solutions to a system of equations, but this time I want to take an algebraic approach. So recall that you have these three different situations. So when you have a system and they essentially have these two lines, they're going to intersect in most cases at just one point. And so that would be the case where you have one solution. But algebraically speaking, if we manipulate this and change it to our slope-intercept form so that we can learn about the slope and the y-intercept, when it has one solution, this is the case where you have different slopes. So if the slopes are different, they are going to intersect each other. Now, this case of no solutions, this is the case where if I draw a coordinate plane, you have two lines, but they're going to be parallel to each other. So we can say parallel lines, and these have the same slope, but different y-intercepts. So essentially, these lines are never going to cross each other, and they're just going to run side by side forever. So that would be the case of no solution. And lastly, you have this case where you have infinitely many solutions. And so if we had some kind of coordinate plane, and what happens here is that you would have one line and another line directly on top of it. So that's very difficult to draw, but you can kind of imagine what's happening. Let me redraw that using a line tool. But you would get these two lines on top of each other. And in that case, algebraically speaking, let me go back to that blue color. This is the case where you have the same slope and the same y-intercept. And essentially, the only time where you have this infinitely many solutions where these two lines are intersecting everywhere, you essentially have the same line. So that's essentially the big conclusion we have, that these are the same line. And often you'll just see that one is a multiple of the other. But in all of these, we just need to figure out what the slopes are and what the y-intercepts are, and then we can tell how many solutions this has. So let's solve each of these for y so that we can change it to our slope-intercept form. So in this case, we have a slope of -3. And for this bottom equation, if we subtract 2x on the other side, so minus 2x plus 8, and then divide everything by 2, we'd have minus x plus 4. So notice they have different slopes. This one is at -3, this one is -1, and their y-intercepts are different. So this is the case where they will intersect, and you will have one solution. And of course, you can set them equal to each other, use substitution, and solve for that value of x, and then plug it back in to find the value of y, if you want to find this exact point. But in these problems, that's ultimately not what we're focused on. We just want to know which of these three cases we have. So let's do more problems. And in all of these, I'm just going to solve each of these for y so that we can find our slope-intercept form. So we'll subtract 8x on each side, so minus 8x plus 14. Divide everything by 2, so minus 4x plus 7. And we'll do the same for the other equation here. And so subtract 8x on each side and divide by 2. You get minus 4x plus 2. So notice these have the same slope, but their y-intercepts are different. So if you were to graph these, this is essentially the case where you have parallel lines. So maybe it'll look not quite like that, maybe more like that, and something like that. But obviously they should be parallel. They have the same slope. So roughly speaking, something like that. And because they're parallel, they're never going to intersect. And so this is the case of no solutions. So let's keep moving. So we will solve them each for y. Now, some of these you might notice one equation might be a multiple of the other. So if you're ever able to just divide by some common factor, then that's ultimately what you should do first. And notice each of these are divisible by 5. So just to make our numbers easier, let's divide everything by 5. And what you get is 4x minus y equals 1. But that's exactly what the bottom equation is. And anytime you have the exact same equation, We could solve this for y, but it will still be equal to the same thing. And so here is where we have two lines that are on top of each other. And so they're going to intersect at every single point. And so here you have infinitely many solutions. And let's do one more. So they're both already solved for y. Now this one's not in our slope-intercept form, so I'm going to switch it so that the x term goes first and then plus y. Remember, if you're ever switching, just make sure the sign stays attached. So the negative is part of the 5x, and the 1 is a positive number, which is where that plus sign came from. But again, notice these are the exact same equation. And so these two equations, these lines, are going to intersect at every single point. And so again, we have this infinitely many solutions.